This time we will start regex fundamentals. And in this one, we will see pattern syntax, character classes, quantifiers, groups, like some general methods and ways to define any regular expression. Regular expressions fundamentals. Regular expressions, or we can call regex, are patterns that describe sets of strings. They are used everywhere, like validating email addresses, extracting data from text, search and replace operations, and parsing structured data. So, learning regex syntax is a universal skill because we can use those in Python, JavaScript, Go, any language. Also, we can definitely use in some command line tools. Even in our IDEs, find and replace thing, we can also use there as well. And in next chapter, we will see how our Java implement these regular expressions and what kind of API or implementation Java provide. So what are regular expressions? Regular expression is a sequence of characters that defines a search pattern. Instead of looking for an exact string, we can describe the shape of what we are looking for. So here we have one example. Instead of checking if a string equals CAT, BAT, or HAT individually, we can write one regex, something like that. We will see like what these brackets mean or these kind of things in this chapter. So we can define some regular expression like that, and this one will match all these three strings at once. So at core, regex answers the question, does this string match this pattern? And we define our pattern. So let's say we will see what this D means, what these brackets mean, something like if we define in this bracket, then this one means exactly this amount or this number. So here, 3 digits, then hyphen, then 4 digits. So if we match with this one, this string, then we will get true here. But if we try to do that with this one, then we will get false here. Okay. So we can define our pattern and we will get our match results. Okay. And our regular expressions can be very complex and sometimes very hard to read, but individual blocks that we use to build that complex pattern, those individual blocks are very simple. And we will see those blocks in this chapter. Okay. First one is literal characters. The simplest regex is just literal text. It matches exactly the text. So hello matches this one, true. Hello matches this one. So here we have capital H. So in this one we'll get false, case insensitive. Say hello matches hello, false. So this matches checks entire string, not any part of it. We will see these methods as well, like matches. We have some others as well. Escape special characters. Some characters have special meaning in our regex. To match them literally, we have to use backslashes. So first special character is this one dot, meaning in regex any character like that. To match literally, we have to use this one. So we need to escape these special characters with backslash. Next one we have asterisk. This one means 0 or more. Then we have plus, 1 or more. Then we have mark here, 0 or 1. Then we have brackets, grouping. Okay. Then we have square brackets, character class. And we will see this one here. In most regex references, we will see like backslash D for a digit. In Java strings, this backslash itself must be escaped. So we write double backslash D. This is a Java specific syntax detail, not a regex concept. So what this mean? We can also remove this one. So in our regex documentation, we see something like this. Okay. And in Java code, we will see something like this. So this one is one Java specific. Okay. So every time we see this single backslash in our regex reference, then we have to use double backslash for that. Okay, now let's move to our character classes. Character classes match one character from a set of options. And this is where we write some complex patterns with the help of character classes. We have some predefined classes here. First one is this one dot, any character except new line. Okay. Equivalent, we don't have any here. So this one is something like we can say wildcard. Then we have backslash D, any digit. Okay, we have equivalent for this one. Then we have capital D, any non-digit. You can also see one pattern here, like small d for digit, capital D, any non-digit. Same case here. Small w means word character, capital W means non-word character. We have equivalent for this one here, A to Z and capital A to Z and 0 to 9, and also we can include underscore here. Next one we have this capital W equivalent pattern. So if you have noticed, we put here caret, and if we put caret like inside brackets, then this one will behave like negation, and if we put this one outside brackets, then this one will behave differently. But for now, if we use inside brackets, then this one will match anything except these things. Okay. Then we have this white space, small s. So tab, new line. This one is one window specific. Okay. And this backslash f. This one is also one older concept. We call this one form feed, and this one we call carries return. You can skip those. Just remember these things. Then we have capital S, non-white space, anything except those. Okay. Custom character classes with brackets, any vowel. We can also define our own classes as well. So we can choose here what should match. Then this one, any lowercase letter, any uppercase letter, okay, any letter, any digit, not a digit. So remember, inside brackets, most special characters lose their special meaning. We don't need to escape this one or this one inside this. So in this bracket, we have one little word in which like those dot, this one asterisk and backslashes, okay, hyphen, those are only special. Anything else will lose their special meaning. So definitely we can do some practice here. So let's say we want to match only letters. So here we can write something. We have to use dot match. Let's define our pattern here. So that will be letters means A to Z. Then inside that, let's also include capital letters as well. So this one. And also we can match here anything. So in this one, we will get true. Okay. Just put here plus sign as well so that we can match one or more letters here. Print this one. And then now we can compile this. We can run this one. You can see we got true here. So definitely we can do some practice. Let's say if we want to match only digit, only single digit. So in Java, we need double backslashes, right? And now if we compile this and if we run this one, so you can see. But if we put here one more digit, then this time we will get false. Okay, because we are only looking for one digit. Now we can move forward with our next thing, which is quantifiers. Quantifiers specify how many times a pattern should repeat. First one is asterisk, so 0 or more. And in this one, we will include this one with B. So we can match like 0 as well. So AC, that's also fine. How many times B should appear? 0 is also fine, 1 also fine, 2 is also fine, 3 is also fine, like that. Then we have plus here, 1 or more. So at least one B should be present here to match this pattern. Okay, not AC. Then we have mark here. So 0 or 1. 0U is also fine and 1U is also fine. Like that. Exactly n times. Okay. So in this one, exactly 3 digits. Then we have n and then comma here. So n or more times. Like that. 1, 2, 1, 2, 3. Okay, at least 2. Then we have n and m, between n and m times. Okay, like that. Like if we have to match, let's say we can see some AC matches, let's say A, B, and then C. So in this one, we will get true. You can see here. But if we put here plus, then this time we will get false. So you can see. So definitely we can practice this. Next thing is greedy versus reluctant. By default, quantifiers are greedy. They match as much as possible. So adding this one makes them reluctant. match as little as possible. We have this string. So this one is by default choice, okay, and this one is greedy. So here what we are doing, we put here dot, then that means we can match any character, right? Any character. This one is wildcard, and then we put here plus. So we will match everything as much as possible. So we will count this thing, and we can also include this one as well. Matches this one entire thing. But if we put here this question mark, then this one is now reluctant, and now we will match as little as possible. So we will only match this time this one. And definitely if you don't have like this or this in between, then we will match whole thing. The point is we will try to match as little as possible. And if we don't have any choice, then definitely we will match the one that we have. Next thing we have anchors. Anchors don't match characters, they match positions in the string. First one is caret. So start of string, like I mentioned, if we use this one inside brackets, then this one will work as negation. And if we use this one outside brackets, then this one will behave like differently. So that is this one. This one will match hello world. So outside brackets, this means that our string, the thing that we are matching, should start with this part. Okay. Then we have this dollar sign end of string. Same thing, just in the ending part. This one will match this one and also this one, that's fine, but not these. Now next one we have backslash b, word boundary. We can match here like that, matches CAT, not scatter. So this one is useful for whole world matching, and without these backslash b's, if we want to search for this one cat, then we will also get this one, because in this one we also have this, right? So if we want to match strictly this one, then we can put boundaries here. Okay. We have a note here. Java's matches method automatically anchors the entire string, equivalent to something like this. These anchors are more relevant when using pattern and matcher for finding within strings. We will see these classes in our next chapter, like how our Java provide the regex implementation or regex API. So automatically, this one anchors the entire string. So if we put here something like dot matches with this one, okay, so this time we will get through here. What we want to see here is, like by default, automatically this matches at caret and dollar sign. So if we add this one, and in last if we add this one, so if we add these two things here, and if we don't add these two things here, then both things have same meaning. Okay, we can also see that one here. So if we only put here, let's say hello, this one and this one is same thing in our matches method. Okay, so if you will see here, we will get true if we run this one, right? Now we can move toward our next thing, which is groups. Parentheses create groups that serve two purposes. First one is grouping parts of a pattern, and second one is capturing match text for later use. Grouping for alternation. So if we put here this pipe operator, then this means or. Okay, like always we know this one is or here. So in this one, if we put here parentheses as well, then this time we will match cat, dog, or bird. So here these parentheses are making groups. So this one is one group. We can understand this one more better in this one. Okay, we added parentheses up to here, and this one is one group. In this one we are matching like Mr., Mrs., or Doctor, any one of them using this pipe operator. Okay, so if we don't add parentheses here, then we will be matching this section, okay, as one over part. So we added parentheses here to create one group, and this time we will match any one of these three, and after that we can match some more part, like you can see here. This one means dot. If you want to match like dot, then definitely you should add backslash here, otherwise this one will be treated as like wildcard thing. Okay, then we have here white space, so we can count this one as well, and then any letter and one or more time, so we can match these things. The next one we have capturing groups. Each group is assigned a number, one based, and we will see these groups in our next chapter as well, like with matcher. And there we will see some examples as well. Right now you can just remember that we have some group numbering here, and which is one based, left to right by opening parentheses. So let's say we have this pattern, right? And we added one parenthesis bracket here and another one here. So this one is one group and this one is another group, right? So group 0 means entire match. And then we start our individual groups. First one is group 1, which is this one. Okay. Match 3 digits. And then we have group 2, match 4 digits, like that. Okay. So our group 0 is always the complete match. And our these groups like group 1, group 2, and so on are the captured portions. And this one is useful for extracting data. So let's say we have one example like we are matching phone numbers. And after that, if we want to pull out only the country code, then we can do that using groups. We will see this one in our next chapter. Now we have named groups. We got in Java 7. So here we increase our readability so that we don't have to count like parentheses. So we can add something like this named group. First one is area. Okay. Then second one is number. Access by name instead of number. So instead of accessing this one like by group 1, group 2, we can access these groups by their names. And first group will be like area, like that. Groups become powerful when combined with Java's matcher class. We will cover this one in our next section. Let's say we have one group that we matched. So in this one, we can access these groups by the names like group of area is this one, group for number is this one. Okay. All right, now let's see some common patterns. Digits and numbers, one or more digits. We have here plus quantifier means one or more. Then we have optional negative here. This one means 0 or 1. So negative is also fine. Text patterns, only letters and digits. We can create our own pattern as well. Okay. Word characters, valid identifier, like start with letter. This one. You can do some practice, that's fine. Now next one is common validations. Simple email, basic note, RFC compliant. Simple email, basic one. You can see this one, phone number, date format, IP address. Regex has limits. Regex is great for pattern matching but terrible for complex parsing. Don't try to validate email addresses with a perfect regex. Our FC spec makes it nearly impossible. For complex formats like HTML, JSON, or XML, we can use dedicated parsers. Okay, so our this regex is one pattern tool, not a general purpose parser. Building patterns step by step. Complex regex patterns are easier to understand when built incrementally. Okay, let's say matching a date like this one. So start with the day, 1 or 2 digits for the day, add the separator, day followed by a hyphen, add the month, 3-letter month abbreviation with capital first letter. Then we have here add another separator and year. In Java, let's say we have this pattern. Then if we match with this one, then we will get true. If we match with this one, then we will also get true. But if we try to match with this one is not valid for our pattern, right? Because we are looking for first uppercase and then followed by 2 lowercase characters. Like that, we can do some practice and then we have quick summary part and we can move forward with our next chapter, which is regex in Java. In this one, we will see pattern and matcher classes.